Similarly, the sodium, when it is react with the oxygen, it forms what? Sodium peroxide it will form. Why they have kept in kerosene oil? Only because it can easily react with the air which is present in the atmosphere and it forms a oxide. That is why they usually keep in a kerosene oil. When you react the metal ion with the ammonia, it will form what? Ammoniated cation and ammoniated anion. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called S-block elements. Under that, we have learnt about what are S-block elements. Under that, we have learnt only the group 1 elements with their general electronic configuration, hydration enthalpy, ionization enthalpy, and we have learnt what is atomic radii and ionic radii, why does it increases or decreases along the period. And also we have learnt very few physical property, that is flame test as well as with a density. Today, let us move on to the chemical properties of group 1 element, and we are going to understand the uses of the alkali metals and anomalous properties of the lithium we are going to understand in this session. Let's see which are the chemical property we are going to discuss in this session. So the first chemical property indicates that the alkali metals are highly reactive and their reactivity increases down the group. That is mainly because of the low value of first ionization energy and because of the larger size and low heat of atomization. As we move down the group, we know that the first element is lithium, sodium, potassium, rubidium and cesium. As we move down the group, what will happen to the size? The size of the atom which is also get increased. The size of the atom which is also get increased, and we know that each of these elements, they consist of one electron in its outermost shell. So it is very easy to remove this electron which is present in their outermost shell, but it is very difficult to remove the second electron because it attains a stable electronic configuration. So that is why these elements, they are highly reactive as we move down the group. Only thing is because of the increased number of shell and also due to the low first ionization energy and also the low heat of atomization. And also as we move down the group, we know that the size of these elements which is also get increased because of the number of shell which is going to add it up. Okay, let's say with the first reaction now, the reaction with the water. Alkali metals tarnished in the air due to the formation of oxide. Already we have understood that alkali metals, they are silvery white solid. When it is exposed to the light or when it is exposed to the atmosphere, it undergo oxidation and the silvery nature of that appearance, it get tarnished due to the oxidation and the formation of oxide. The formation of oxide and hydroxide on its surfaces. The alkali metals, when it is burnt in the air, they forms a different kinds of oxide. For example, alkali metals on reaction with limited quantities of the air, it forms a normal oxide. Here I have a general reaction. This is a general reaction. This is my elements. Okay. So M stand for metal here. It may be lithium, sodium, potassium, rubidium and cesium. Okay. When it is react with the oxygen, it forms what? Manganese oxide. Sorry, it forms what? Metal oxide. It forms metal oxide. When it is heated with the excess of air, lithium forms a normal oxide and sodium forms a peroxides, and whereas potassium and rubidium and cesium, they forms a superoxide. Here I have a general reaction to show with the lithium, sodium, potassium, rubidium as well as with the cesium. So first I will go with the lithium now. We know that when the lithium heated with air which consists of oxygen, it forms what? Lithium oxide. Similarly, the sodium, when it is react with the oxygen, it forms what? Sodium peroxide it will form. Similarly, the metal, when it is react, it may be potassium, rubidium and cesium. When it is react with the oxygen, it forms superoxide. I can write one more example for that. I will take potassium, react with the oxygen, it forms potassium superoxide. Similarly, the cesium, when it is react with the oxygen, it forms cesium oxide, that is a superoxide. Similarly, the rubidium, when it is react with the oxygen, it forms what? Rubidium superoxide. This is how, this metals such as potassium, rubidium and cesium, they forms a superoxide when it is react with oxygen. Similarly, the potassium, when it is react with the oxygen, there is a one exceptional case here. It forms what? Potassium superoxide. Our potassium can also form a superoxide or it can also form a potassium superoxide. So this is how, our metals which react with the oxygen and forms the respective oxide. Remember, only the element called as lithium which forms a normal oxide, whereas sodium which forms a peroxide, whereas potassium as well as cesium and rubidium, they forms a superoxide. So hope you all understood with the reaction with the air. The oxidation state of potassium is, that is, potassium superoxide is +1. Since it consists of superoxide ion, that is O2 minus ion. The reactivity of the alkali metals with oxygen increases down the group with the increased stability of peroxide and superoxide. As we move down the group, what happens to the reactivity? Reactivity which is also get increased. Reactivity is also get increases as we move down the group. That is mainly due to the formation of peroxides and superoxide. In all this oxide, the oxidation state of alkali metal is +1. Lithium shows exceptional property in reacting directly with the nitrogens of the air to form a nitride, and as well as because of their high reactivity towards the air and water, they are normally kept in kerosene oil. So hope you know that when you visit to the lab, you might have been seen with the sodium metal will be usually kept in kerosene oil. Why they have kept in kerosene oil? Only because it can easily react with the air which is present in the atmosphere and it forms an oxide. That is why they usually keep in a kerosene oil. Okay, this is how, as we learned from the reactivity with the oxygen, we have understood that as we move down the group, the reactivity is also get increased because of the formation of oxide, superoxide and peroxide. Next is reaction with dihydrogen. Alkali metals react with dry hydrogen at around 673 Kelvin to form a colorless crystalline hydrate. It will form. It forms what? Hydrate. All the alkali metals are hydrates, are ionic solid with a high melting point. Again, this is a general reaction where our metals react with the hydrogen. It forms what? Metal hydrate. You can take one example here. I'll take with the sodium. React with the hydrogen. It forms what? Sodium hydrate. So you need to balance the equation. Similarly, you can take with the potassium also. React with the hydrogen. Forms what? Potassium hydrate will be formed. potassium hydrate, and you need to balance the reaction. Similarly, you can write for the rubidium, that is react with the hydrogen, forms what? Rubidium hydrate and balance the reaction. Okay, this is how when the alkali metals react with the hydrogen, it forms what? Hydrate. It forms a metal hydrate. Next is reaction with the water. Alkali metals are known to have larger reduction potential value. As a result, they can act as a better reducing agent as compared with the hydrogen. Hence, the alkali metal react with the water and it forms what? Hydroxide with the liberation of hydrogen gas. So, this is my general reaction. By showing the metal react with the water, it forms what? Metal hydroxide will be formed with the liberation of hydrogen gas. That is why I have taken out one example here, that is sodium react with the water molecule, it forms what? Sodium hydroxide with the liberation of hydrogen gas. Similarly, you can take with the potassium, it will be react with the water and it forms what? Potassium hydroxide with the liberation of hydrogen gas. Is it right? And you need to balance this reaction to show that the equation should be balanced on both the sides. This is how our alkali metal, when it is react with the water, it forms what? Hydroxide. Metal hydroxide will be formed with the release of hydrogen gas. And the reaction has become more and more violent as well as move down the group, and the lithium react very gently, whereas the sodium melts on the surface of the water and the molten metal moves vigorously, and sometimes it catches a fire, and potassium will be melts and sometimes it catches a fire also, as well as with the rubidium and the cesium. So, in your lab also you would have observed that when you take the sodium metal, when it is dissolved in water, you would have observed that the entire beaker will be started warming. This indicates that the sodium, it will react vigorously with the water and reduces or releases the excess of heat, because it's an exothermic reaction. When you react this metal with the water, it forms a sodium hydroxide, or the metal hydroxide will be formed with the liberation of hydrogen gas. Next is reaction with the halogen. Alkali metals react vigorously with the halogen to form a metal halides, and the general reactions will be written like this, and they are ionic crystalline solid. So, here I have a metal, it may be lithium, sodium, potassium, rubidium or cesium. When it is react with the halogen, it forms what? Metal halides will be formed. So, I can write this reaction by considering the sodium. When it is react with the halogen known as chlorine, it forms what? Sodium chloride will be formed. So, sodium chloride will be formed, and this is a metal halide. So, the sodium is a metal and Cl is a halide. Similarly, you can go with the sodium, react with the fluorine. Okay, it gives us to 2NaF. So, this indicates that the metal, when it is react with the halogen, it forms what? Metal halides. The reactivity of the alkali metals with a particular halogen increases from lithium to cesium. On another hand, the reactivity of the halogen decreases from F2 to I2. Okay, this is another one of the important thing you must remember, and it will be asked for your competitive exam. Okay, next is solubility in the liquid ammonia. All alkali metals, it will dissolve in liquid ammonia and giving up with the blue solution, which are conducting in nature, and this solution which consists of ammoniated cation and ammoniated electron. So, here you can see that when the metal loses its one electron, it will get plus charge. So, when it is react with the ammonia, or when it is dissolved in an ammonia, it will form what? Metal ammoniated cations and ammoniated electrons will be formed. Ammoniated cations and ammoniated electrons will be formed. The blue color of the solution is due to the ammoniated electron, which also absorbs the energy corresponding to the red regions of the visible light for the excitations to the higher energy level. The transmission of the light is blue and which imparts the blue color to the solution. The electrical conductivity of the solution is mainly due to the both ammoniated cations and ammoniated electron, and blue color of the solution is standing slowly and liberate the hydrogen gas, results in a formation of amide. So what will happen when you react the metal ion with the ammonia, it will form what? Ammoniated cation and ammoniated anion. So this ammoniated cation, it will liberate all its hydrogen, and giving rise to amide. And remember, this nature of formation of ammoniated electron and ammoniated cations, which will be responsible for formation of blue color in the solution. Okay, this explains that how does this alkali metal can also dissolve in liquid ammonia and give rise to the ammoniated cations and ammoniated electron. Next thing is reducing property of alkali metals. Alkali metals have more negative values of reduction potential. Therefore, they have a strong tendency to lose the electron and act as a very good reducing agent. So, all the alkali metals, they have a negative reduction potential. Is it right? They have a standard reduction potential that will be in the negative value. This indicates that all this metal, they can easily lose their electron, hence they act as a very good reducing agent. And the reducing character increases from sodium to cesium. However, the lithium is the strongest reducing agent and due to the larger enthalpy of hydration. So, as we move down the group, this reducing nature of this metal will be increases from lithium to cesium. But we have one exceptional case with the lithium. As we compare the lithium with the sodium, lithium is very good reducing agent because of the high enthalpy of hydration in the lithium as it is compared with the sodium. And the reason is the alkali metal, they have a very low ionization energy which will be decreases down the group so that it can easily lose their valence electron and act as a very good reducing agent. So, always remember, if I say it is a reducing property of alkali metal, this indicates that these metals can easily lose their electron. We know that all this metal, as we move down the group, it will be consists of one electrons in their outermost shell. Since it consists of one electrons in their outermost shell, it can easily loses that electron and become a very good reducing agent. But there is a one exceptional cases with the lithium. Even though it belongs to this group, it will be act as very good reducing agent as it compares with the other elements in this group. Next is uses of alkali metal. Let's see with the uses of alkali metal, where we are using this alkali metal, let us understand now. Lithium metal will be used to make the toys, and with the lead to make a white metal bearing with the motor engine, and lithium with the aluminium which makes a aircraft parts, lithium with the magnesium which will be makes the armor plates and it is used in a thermonuclear reaction. Lithium will be used to make the electrochemical cell as well as, and the sodium will be used to make the sodium and lead alloy needed to make the tetraethyl lead and tetramethyl lead. So, these are the organolead compounds which will be used as a anti-knock additives to the petrol, and nowadays, the vehicles are also uses the lead-free petrol. And liquid sodium metal will be used as coolant for the nuclear reactions or in the nuclear reactors. Potassium play a very important role in biological system because potassium will be itself used as a fertilizers, and cesium, which is also used in photochemical cell. So these are the uses of group 1 element which is there in our periodic table. And next is anomalous behavior of lithium. As we found out from the physical to the chemical property, there is only the element known as lithium. This shows its behavior is different from the others. Is it right? Other group of element. Why it is like that? Let us understand that the different nature of this lithium as it is compared with the other elements in the group 1. Okay? The lithium is the first elements of alkali metal. They differ from the rest of the other group elements in this aspects. The first one is the presence of smaller size of lithium atom. As we move down the group, we know that the sizes of the element which is also getting increases. We know that the first element is a lithium which will be having very small size of the lithium ion. And we know that our lithium molecule, or lithium element, they shows a higher polarizing power. The charge on the size ratio, charge to size ratio, it is known as polarizing power, resulting in increased covalent characteristics of its compound, which will be responsible for their solubility in a organic solvent. All the lithium compounds you would have seen that they will be soluble in organic solvent only because of the high polarity of their nature. And comparatively, the high ionization energy and the low electrode potential characteristics. Because of the smaller size, we can easily remove the one electron, hence the ionization energy is also very less. And we know that in the lithium only 3 electrons will be there. It is very easy to obtain the second electron also. So this indicates that they have a very low ionization energy and also, they have a very low electrode positive value. And non-availability of d orbital in its valence shell. We know that the electronic configuration of the lithium will be written like 1s2 and 2s1. So it will be stops at only s orbital. There will be no d orbitals in its valence shell. So this makes the lithium to behave like a different from the rest of other element, and they have a strong intermetallic bonding. So when it is reacting to the other metal, it forms a very strong interbonding so that it exhibits a different property as it is compared with the others. In the next session, we are going to discuss with the differences between the lithium with the other group of alkali metals. By this, I like to say that what are all the chemical property which I have discussed in this session, it is very important for the examination point of view. Have a look on it and try to make a note. We'll meet you in the next session. Till that, take care, be safe. Thank you.